Hi, today we're going to talk about Chapter 8, talking more about inductive reasoning, enumerative induction, and looking at target populations and samples. Okay, so that's my short version of that. What we're looking at today is a little bit of a review from way back in Chapter 3, when we talked about the differences between inductive logic and deductive logic. We've been spending our time in Chapter 6 and 7 all about deductive logic with our truth tables and Venn diagrams. And so now we're shifting away from that. I know, much rejoicing. We're shifting away from that into inductive reasoning, which really does look at kind of what we can think about, what we can go to if we have certain facts, okay? Deductive knowledge, deductive logic is always looking at things that we can prove, things that are either right or wrong, true or false. And we have a lot of that in our world, but we need to know more things. And so what happens with our deductive logic can only take us so far. Our inductive logic takes us from what we know for fact and helps us understand what could be, what is probably true. And that's kind of the reminder part. Let me get my little marker here. Inductive logic, remember, when we looked at this back in Chapter 3, we learned that we have a couple of things that are different, okay? We have probable evidence, okay, not conclusive, but probable evidence. So if my premises are true, my conclusion is probably true, likely but true, mostly true, okay? Probable evidence, we have strong or weak structure. Okay, how well does this particular information follow the rules we already know? Strong structure means that there are a lot of really good correlations. We have good evidence. We can reasonably make this particular assumption or assertion. Weak structure, we can't do those things. We don't have enough evidence. We don't have a big enough sample size, those kinds of things. Our last piece, we have cogent or failed truth. Okay, this is our content issue. And really, once we get to, as we did with deductive, once we get to this last part, we have to already know these two. Okay, we have to know that what we're looking at, our evidence is probably true. What we're talking about is true most of the time, true in most cases. Okay, what we're looking at also for structure, if we want to get to a cogent, a thoughtful argument, then we have to have structure that works on lots and lots of levels, okay? And so inductive logic, inductive reasoning is not as precise or pristine as our deductive, but this is where we live most of the time, okay? When we're looking at medical field, when we're looking at scientific stuff, when we're looking at breakthroughs in anything, technology, science, psychology, we're looking at things that we can't immediately or maybe ever test 100%. And what we're doing is saying, okay, if we know this group of rules are true, what can we say then about this other incident, this phenomenon, or this state of affairs? Okay, you're going to see those kinds of vocabulary quite a bit in chapters 8 through 11. Okay, so this is our inductive logic, kind of short and clear things. And remember, if my premises are true, then my conclusion is probably true. The other thing we have to remember about when we're looking at particular arguments from the book or particular arguments we find out in daily life is that we're looking at the things on the page, okay? This isn't necessarily an opinion piece. This is, I know these things are absolutely true, what can I then say about them? Any scientific hypothesis, any medical trial, any kind of psychology breakthroughs, anything like that, we're looking at things that are not absolute true, but things that we can work with, okay? Things that are probably true or true most of the time, true for most people, and not in that relevant sense, but in the fact that, okay, we all have different physiologies, we all have different backgrounds. Sometimes what works in one case isn't going to work very well in another, and we all know this is true with any kind of medication. So we're looking at inductive logic. Here's our kind of background, okay? We're going to look at, in Chapter 8, we're going to look at 3 different types of inductive logic, and then we're going to move on with chapters 9 through 11 and look at some particular types underneath these. The first one, and what we're going to look at in this video, is enumerative induction. This is the first half of Chapter 8 in Dr. Vaughn's book, The Power of Critical Thinking. And really, enumerative induction, okay, I'm going to give you a couple little definitions here. Enumerative induction, okay, it reasons from particulars or parts of a whole to conclusions about general things, okay, or about the whole itself, okay, the whole group. And we're going to get some interesting vocabulary here, because when we're talking about enumerative induction, we see this all around us, okay? It gets done all the time. The most popular way of kind of looking at this is through opinion polls, okay? Election polls, political issues. Somebody wants to know whether there should be a stoplight at the end of your street. Well, they have to ask, okay, is this going to create less accidents, more accidents? What do we need here? How hard is it to get in and out? All those kinds of things. And so we're asking questions about a particular set of ideas so that we can reason to a general conclusion, okay? So if I'm looking at this enumerative induction, this general or whole thing is called the target population. It's the target because it's what I'm aiming for. I want to know what this whole big group of things do, or what this whole big group of people think. And for some reason, usually because there's too many of them, I can't talk to all of them, okay? And so I have to look at a small piece of them, and that small piece is my sample, okay? So my target population is the whole group under consideration or under study. Okay, they're the ones we want to know about. The American people think this. Well, there's 345 million Americans these days, give or take a few thousand, and I don't have time in my whole life to ask them even one question apiece, let alone all the things I need to know in order to make a new product, say. So I'm going to look at a particular section of that whole target, and that's my sample, or sample population, okay? My sample population is the subset I'll use to get to my answers, okay? Is that the official definition? No, but it'll get you there. The sample population is that subset of the target that represents, both in number and in demographic, however you want to define demographic, the target population under study, okay? And if you're looking in your book, you have some definitions here on page 266, okay? The observed members of the target population are what we call the sample, okay? We can't talk to, watch everybody, so we pick these folks and we try to hope that they are going to give us the answers that we need. Sometimes it works really well. Other times, way out left field, okay? One of the other things we have to think about here is our sample population has to match our target population. And that's the interesting part, okay? So if I have a sample, okay, even say of JCC students, okay, there are about 6,000 JCC students if you count everybody who is currently taking classes at JCC, part-time, full-time, high school, CCP, whatever, okay? If I want to know how many of those students think we need more parking spaces, okay? I can't really walk around and talk to everybody, so I'm going to ask a few. How many is a few, okay? So my sample has to be relevant, both in size and demographic. Wow, my handwriting sucks today, sorry. Okay? Size-wise, okay? Size can be an interesting issue. When we're talking about the American people, 345 million, most of the time, when we're looking at political polls or opinion polls about whatever, we're not looking at a huge number here. Sometimes we're looking at as small a number as 1,000, okay? You do that kind of math, right? So 345 million down to 1,000, okay? That's about 0.03%. That's nothing, but it's still 1,000 folks. Now, if we're doing really good work, and this is kind of the standard thing, if we're doing really good work, we're using a totally representative, totally random sample, and we have 5,000 eligible to vote adults. They can tell us with pretty good accuracy how the rest of the country is going to vote. But we have to be careful, okay? That, okay, less than half of 1%. That's small, but 5,000 people, that's a lot. Think about how many folks that is, okay? When we think about our size pieces here, we have to be very careful that we are representative, okay? That means all of these relevant qualities are present equally in our sample as they are in our target. So I have just as many folks who are college graduates, high school graduates, socioeconomic factors are about the same. I have men, women, transgendered. I have all kinds of religious and political affiliations. I have to kind of sift that and then say, okay, I need 5 of this and 6 of this. And we have programs that are very good at doing that, okay? But still, we have to be careful about our relevant qualities, okay? If I don't have the same demographics, the same percentages across the board, my answers, my conclusions are going to be slightly skewed, okay? Sometimes greatly skewed. So it depends a lot upon how representative we can get and how many relevant qualities we want to screen for, okay? All the time thinking about this idea of randomness. Now, we're not talking about kind of your own train of thought. You know, have your friends ever said, well, that was really random? Not that kind of random, but the random that says every person, every element in my sample has every element in my target population has an equal chance of ending up in my sample. I'm not basically stacking the deck, okay? And randomness is hard for human beings. We like pattern, okay? Even those of us that are fairly random in everything else we do, we still tend to like pattern, okay? That's why we can read words on page. We like patterns. Randomness in this way is really hard for us to do, but we have to try really hard when we're looking at target populations to randomize so that we're not tainting our sample with our own agenda, okay? So randomness in this case is a good thing. Our sample needs to be relevant, okay, both in size and in our demographics. Demographics kind of translates into our relevant qualities, okay? Whatever is going to be useful in determining how many and what kind of folks or things we need in our sample. And then making sure that we're not just choosing the ones we like or the ones we don't like, depending upon which way we want our sample to go, okay? Now, if I think about how all of this is supposed to work, I have a few things that are going to help me and a few things that are going to hurt me, okay? I have these relevant qualities that are influenced by and should influence this idea of a relevant property. Okay, this is the thing I need in my conclusion. I want to know, for instance, the parking lot debacle. Okay, I want to know, do we need more parking? How easy is it to find a parking space in the Wilson Building parking lot during the midday? Okay, you have class at 11. How early do you have to be here in order to get a parking place and get into class by 11? How far do you have to walk? Okay, those kinds of things. So my relevant property here is I want to know about parking, but I have to think about all the qualities of the folks that need to answer this question. Okay, I need to know how many folks carpool. I need to know how many folks drive individually. How many folks actually drive between classes? Do you park once and then walk the rest of the day, or do you park each time? Makes a huge difference in what I'm looking at as far as my relevant property here about parking places. So my relevant qualities here influence my conclusion. What I'm looking for in my conclusion has to be relevant to these qualities here. Now, whether or not you drive a 66 Mustang or a 2007 Toyota, that doesn't make any difference. They take up the same space, okay? So, relevant qualities. The other thing here, we end up with some interesting issues, okay? So, I have all of my pieces together. I do my survey. I get answers back, okay? I get all kinds of answers back, and I have to figure out, as the tabulator, how I'm going to count things. Okay, how long does it take you to walk to class? Where do you park? How does that work? All of those things get figured into my yes, we need more parking. No, we don't. Okay, so my conclusion is that we need more parking. Okay, well, somebody has to pay for that. So anytime you've got money on the table, you've got to figure things out pretty closely. I have, say, 70% of all of my respondents say we need more parking. And I'm going to tell the Board of Trustees 70% of the students at JCC say we need more parking. Can I do that with a clear conscience? Can I do that? Can I make that claim from my conclusion with all the pieces I have? Well, okay. Say we have, I'm going to give you a little bit of specifics here. We have 6,000 students. I was able to ask 600 for my respondents, okay, so that's my sample. Okay, that's 10%, that's not bad. Doesn't sound good, but in the case of all of this stuff, yeah, it's very good. 10% response is great. So 70% or 420 of these said, yes, we need more parking. How much confidence do I have in those pieces? Okay, and that's one of our special, one of our vocabulary words. This is, sorry, I have to look at my little piece here. Ding, ding, ding. I know, I'm wasting time here. Hold on, I'm going to go there. My confidence level, this is on page 275. Okay, my confidence level is basically a grade. Okay, my confidence level is how well this particular sample represents this particular target audience. And if I've done my work right, okay, my 600 respondents, are the same demographics as my target, same percentages of folks who carpool, folks who drive individually, folks who get dropped off, folks who ride public transportation, all of that, okay? Folks who are here first thing in the morning, folks that are here midday, folks that are here in the afternoon or evening, okay? I've got all of that taken care of. I did my sample really well. I asked really good questions. Here's what I got back. 420 say yes. My confidence level in this is then probably about a C plus or a B minus, okay? And that's not, you know, we like A's, right? It's really, really, really hard to get an A on a confidence level, because in order to do that, you would have to match exactly. And 10% respondents, although that's a very good number in the land of questionnaires and such, 10% out of 6,000 means I've got some room for error, okay? So confidence level, C plus, B minus, very good. Okay, and then my other piece, my margin of error, is probably plus or minus 10%, which isn't horrible, okay? Now, it doesn't have to match this number here, the 10% respondents, but I'm looking at a lot of variables here. And even though I've been very careful with my relevant qualities, my variables still, because there are probably 14 or 15 of those, that picks my plus or minus up a bit. So even if I say, okay, I say 70%, it may be as high as 80%, it may be as low as 60%. So I can still say there's a significant amount of folks here at JCC who think we need more parking. Okay, so my margin of error plus or minus 10. Now, if you're really, really good, okay, you've been doing this a long time, you run a computer program, everything's great, you may get this down to plus or minus 4%. Again, I can't write today. That's probably as low as it goes, okay? Unless you're asking computers about computer stuff, then you can get a little bit better than that. But for folks, about 4%. So I have to be careful how much credence I put behind my numbers and what I get as far as confidence level and margin of error, okay? So, enumerative induction, we're talking about parts of a whole, okay? 600 JCC students were surveyed, 420 of them said, yes, we need more parking. I have 6,000 people I need to take care of, and I can do that with pretty good confidence and not much error in the grand scheme of things. Okay, so that's not too bad. When I get to looking at and evaluating other people's arguments in this particular mode, okay, somebody is trying to figure out, should we build a new bridge? Okay, lots of money, millions of dollars. And we need to do a lot of studies, okay? Why here? Why this particular spot? How is it going to help take the stress off of other places? How is it going to impact the environment? How is it going to impact the neighborhoods, the wildlife, the everything? There's a lot of stuff that goes into that. Can I still make the recommendation? Well, a lot depends upon all those numbers that show up. And so when I'm evaluating somebody else's argument, I have to look at what they've done with the numbers and where they got them, okay? And we talked about this before, back in chapter 4 and 5, about percentages and how those can get kind of chancy. Be careful, too, when you're looking at arguments and somebody is talking about what you think is an average, okay? The average cost of this particular project. This type of project, the average cost of adding 100 parking spaces to this kind of area. What are we going to talk about here? Are we talking $20,000? Okay, so $200 per parking space. That sounds like a lot for 8 by 10 kind of thing. But we have to think about all the stuff that goes into getting that particular space prepared, making sure we're not negatively impacting the environment in a way that's going to change the ecosystem around here. how many geese are we going to displace? Okay, that kind of stuff. And so when I'm looking at the math part, I'm looking at 3 different things that show up. Okay, we talk about means, we talk about modes, and we talk about medians. And although they tend to be used for average, they don't all mean that. Okay, when I'm talking about a mean, I'm going to change my color here so you can kind of see differences here. I don't erase too much. When I'm talking about a mean, that's my actual average. Okay, I take the number of things and add up all their values, and then I divide by that number of things. Okay, so like an average test score for one of my classes could be an 86.7. Okay, 22 people took the test. They ranged from 102 to 68% on the test. The class average was an 87 point something. It's a B. It's pretty good. Does that mean everybody got an 87? No. Okay. It means in the grand scheme of things, that's kind of the midway point, or actually that's the average point. If I'm looking at the midway point, median just means middle. I line all of those scores up, and I have 23, so I go up here to number 12, and that's my median. Okay. Is it going to be 87? Maybe. That's just a coincidence, though. Okay. Median just means middle. So when you're looking at median incomes or median house prices, that's not an average. That's just kind of what's in the middle. The other one, and we don't see this one very often, is the mode. The mode is basically what score, what number shows up the most times. So same class, I had 5 people who got a 91 on the test. Just 91. That's just how it worked out. Okay, so the most common score on the test was a 91. The median was an 86. Okay, the average was an 87. They're all pretty close, but it doesn't always work out that way. Okay, so be careful when you're looking at other folks' arguments, how they're using numbers and what they're using as their numbers, what they're calling them. Okay. The other thing in this particular section, we talk about opinion polls, and that's mostly what I've been looking at here. Okay. Now, when we're looking at enumerative induction, it's not just opinion polls. This can be all kinds of things where we're trying to see how certain things lay out. Okay, think medical trials. When we're looking at a particular medication, we're looking at a new medication that is supposed to help this particular thing. Okay, so there are lots of new meds out there for Crohn's disease, and what happens before they get put out on the market is they go through a series of trials. They start in the lab and they do simulations. Okay, if this particular, we're trying to reduce inflammation, we're trying to reduce ulcers and scarring and all of that kind of stuff, make people feel better as well. And so we're looking at, okay, if we give them this, it's going to heal the ulcers. Okay, it's going to heal the breaks in the colon and all that kind of stuff, but it's going to send their blood pressure into orbit. Okay, not a good fit. So we try something else. And all of those trials end up trying to figure out our target population, folks who are sick with Crohn's, and then we're trying to only do a sample because we have millions of folks who suffer this way. When we're looking at a target population, we're trying to make as little side effects as possible while producing a positive outcome. That's hard. It's really hard. And so we want to do these sample populations. We want to look at enough folks who are demographically relevant. They actually have to have Crohn's for this to work. We also have to look at physiology. Okay, what kinds of things help the colon but don't hurt your circulatory system, your endocrine system, all those other things. And it takes a while. Sometimes it takes a long time to figure out how does this really work, this particular medicine, and what does it do to the rest of the body. We don't want to make things worse for them curing the Crohn's and then give them a heart attack or a stroke or something like that. So this isn't just about opinions. This is about anything we want to look at that has to do with a huge group versus a smaller sample. And the sample itself is the key to all of this. The sample has to be relevant. It has to match the target population as much as possible. And that's easier when our target population is homogeneous, okay, which just means a lot the same. If we have a target population that is, okay, we're talking menopausal women, okay, so we're talking women of a certain age. We've got a lot of the physiology kind of controlled there. What do we use to reduce hot flashes? Okay, these things work, but the side effects are ridiculous. These other things don't work as well, but there's no side effects. And so we have to think about how the target population looks in lots and lots of different ways versus what our sample size can be. More homogeneous rather, means we can have a smaller sample size. The more diverse our target population is, the bigger our sample size has to be, just to cover all the bases, okay? So a lot of things go into figuring out whether our enumerative induction is going to work, whether it's strong or weak. And the two basic ways this thing can be weak is if our sample size is too small. Okay, we end up with that hasty generalization that we've been talking about since chapter 3. And it has to be relevant. Okay, it has to match our target population in all the relevant ways, or it doesn't work either. Okay, and there are a couple different ways that we can have that problem. When we have what's called a self-selecting sample, and this happens all the time. So a particular website puts a little question up and says, how many of our readers think this? Okay, how many of our readers think we should outlaw air conditioning units that use Freon? Okay, because Freon is polluting the environment, it's bad for the birds, whatever. Okay, and they have 20,000 people who click the little button, no, we should not do that. So they can say American people believe we should not bother with we should not get rid of air conditioning even though it messes with the environment. 20,000 is a lot, right? It's more than our 5,000 target here, right? But is it representative of the whole of American society? Well, no, not everybody goes to that website. Not everybody who goes to that website clicked on the little box. So we have to be careful about how we say things. Now, they could say most of our readers, okay, or most of the people that took this survey think this. We have to be careful to kind of qualify our particular conclusion, and then we can use it legitimately. Most of the time, those kinds of things are just for fun. They can't really be used for policy or anything else, but think about who and when and where when we're looking at sample sizes and how they work, okay? I'll come back in a little bit and do the rest of chapter 8, but this is enumerative induction, and we're onward for next time. Thanks.